Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISIM Stat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
Today we are going to solve this interesting problem of IIT JAM MS 2020. So we are given alpha and beta real constants, we are given that limit x tends to 0 plus 0 to x alpha t square by 1 plus t to the power 4 dt by beta x minus sin x is equal to 1. This limit is equal to 1. Then we have to find alpha plus beta. Let us proceed to the solution part. We are given this limit x tends to 0 plus 0 to x alpha t square by 1 plus t to the power 4 dt. In the denominator, it is beta x minus sin x, and this limit is equal to 1. We are given in the question. So we need to find alpha and beta, and hence calculate alpha plus beta. Here we will use the indeterminate form, and hence we will apply the L'Hopital rule. Let us evaluate the limit first. So the limit x tends to 0 plus integral of 0 to x alpha t square by 1 plus t4 dt by beta x sin x. We know that it is the indeterminate form, because if we put x0 here, we are getting the numerator as 0, and we are also getting the denominator as 0. So it is a 0 by 0 indeterminate form. And we are already given that this limit exists. So this limit, we are given that the limit exists and it is equal to 1. By applying the L'Hopital rule, we differentiating the numerator and denominator using Leibniz theorem, we are getting limit x tends to 0. Differentiating this limit with respect to x in the numerator and denominator, we get alpha x square, and in the denominator we get 1 plus x to the power 4 into beta minus cos x. Again, we know that this limit will exist because this limit already exists according to the question. So this limit will exist when it is in the 0 by 0 form, which will happen only when beta minus cos 0 equals 0. Now what does it mean? We are saying that this limit will exist because this limit already exists, which is given in the question. It is equal to 1. So if we put x equals 0 in the numerator, we are getting 0. So so that the limit exists, we need to make the denominator also 0, so that it becomes a 0 by 0 indeterminate form, which means if we put x equals 0, this part becomes 1 and this part becomes beta minus cos 0, which needs to be 0 for the limit to exist, which means beta has to be 1 for the limit exists. So we are getting the value of beta to be 1 so that the limit exists. Now again continuing our procedure and evaluating the limit, we get limit x in 0 plus 2 alpha x. Again it is in the 0 by 0 form, and again differentiating by L'Hopital rule, we are getting this big quantity from now just putting x equals 0 in the denominator, we are getting it as 2 alpha. So the limit, we are getting the value of the limit as 2 alpha, and we know the limit exists and it is equal to 1 according to the question. So alpha turns out to be half, which is 0.5, and we have already calculated beta to be 1. So alpha plus beta turns out to be 1.5. I hope you like the solution. Please do share the channel for further interesting videos. Thank you.
To book a trial class for your preparation courses of IIT JAM MS, ISIM Stat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel.